Okay, so this is the second time that we're doing this. We did the first one last week, so hopefully you guys saw that one. But we're kind of tentatively calling it Rambling with Ryan, because that's what he's good at.
Ryan's Ramblings.
Ryan's Ramblings.
Rambling Ryan.
Right, the Ryan that rambles. Anyway, because that's what he does. That's how he lives. That's how his life is. He just rambles a lot. And it's usually at me, but now it's at the internet. And all of you fine people. So if you haven't seen last week's episode, I guess is what we'd call it, an episode.
What else would you call it?
Segment.
I like episode better.
Okay. So if you didn't see that one, that was about digital currency, right? So I still have a bag full of a variety of other things. I've actually added to this bag because you rambled at me. Yes. Because you had other subjects this week that I was like, oh, I'm adding that to the bag because he's still talking. So this could solidly be a 5-minute segment, if not a podcast. So he's going to draw out of this bag of subjects and talk about whatever's on the subject for like 5 minutes. And then we encourage everyone that sees these to ask questions or add comments or feedback or whatever, because we're talking about doing a podcast-ish, I guess, like a 30-minute thing. And so if people have interest in whatever the topic is in here, then they can post stuff and then you can address it on a podcast. And if it's something that we can answer, like if it's a question about something, then it can be answered in the comments. So so comment, feedback, stuff like that on whatever the topic is. If you have any questions, and definitely follow the page, share it to all your friends, because they all want to know what Ryan's brain is like, I'm sure. But
I just want to know what's in that bag.
I know, you can't even stand it. So I don't hide this, and I probably should, but he says he doesn't look at them, and I trust that he doesn't because he kind of likes the game. So he still doesn't know what's on any of this stuff.
The fun part for me is I get to talk about whatever I pull out of there.
That's true. Yes. And I have to try to prompt. I'll try to prompt so it's not quite so, I don't know, Ryan-esque. It's a little bit more people-friendly, I suppose, if there's something on it. And hopefully we're going to... So the last one was a pretty good one. There's a couple...
I do digital currency of the very first one.
It figures.
It does figure.
It figures. There's a couple in here that are like really weird and random because it's how you think. And there's a couple in here that are potentially really boring. Sorry. He's interesting, but sometimes not to like the general population, I guess. So
we'll see. Every episode's going to be a winner.
I know. So we'll see. We'll see if this one is. All right. Go.
I can't wait.
Just take one piece because they clump together. Oh my gosh, those are all clumped together. Don't unfold all of them. What are you doing?
I'm just trying to get just one.
I think you have just one.
Is that just one?
I don't know.
Okay, here we go.
Okay.
Computers. What is in this bag?
Okay, so this is such a broad topic, but I did that for a reason because it's like you make your living on a computer.
I do.
And I don't. You can talk about anything though. You can talk about what you do on computers. You can talk about where computers came from. You can talk about how they're built. I don't care. Talk about something about computers, but it's a broad topic. You've got, hold on, I'm setting my timer. Wait.
What's my time limit?
5 minutes.
Okay.
All right. Talk
a lot
fast.
to cover in 5 minutes.
The history of computers, according to Ryan.
All right.
Okay, and I'll try to ask questions as we go to keep it in the stratosphere.
Okie doke.
Okay, ready? And
Let's
go.
go.
Computers.
All right. Well, let's start with what is a computer.
Oh, no. Come on.
I know probably everyone's like, I got this, but do you really?
Do you know that people are watching this on a computer?
Yeah, but
of some sort?
Nobody knows how they work, me included. It's just a magic rectangle that's going to bring you information somehow, right? Well, there's a lot that goes into building a computer and making a computer, and the whole history of how we got to what are computers is pretty amazing. Did you know you can build a computer with water?
Like just water?
Well, you need some other stuff.
Right.
But maybe like water and buckets and wooden levers. And you could build a computer with water and buckets and wooden levers. It wouldn't be a very good computer.
I was going to say, would it video this?
No.
No.
Unless you had a really lot of water and buckets and wooden levers, it would take quite a few of those.
Maybe a piece of glass for video.
Well, and furthermore, a camera is not a computer. A camera is a different piece of technology, and you need at least that to video something.
Oh, okay.
But a computer is something which performs computation.
Oh, God.
Seems like an obvious answer, right? A computer computes. But what is computation? Computation is fundamentally mathematical problems. And most people know computers are made of ones and zeros.
Binary.
Binary. And so when we say, and that's kind of the iteration of computers that we have. And it's because computers that we have are all built on something called a transistor. And the way that we use a transistor is as a switch. And a transistor, there's a lot of cool things a transistor can do. A transistor can be an amplifier, for example. So we don't use them for that, particularly in computers and computation, but we do use them as a switch. So what a switch means is that it's either on or off. And a transistor takes an input and then can switch on that input. And this is why computers operate in binary, is because the fundamental unit of a computer is a switch, something that switches on or off.
So which one's on and which one's off?
1 is on and 0 is off.
Damn it, of course you knew that. So you'd be like, I don't know, look it up.
It doesn't actually matter. I mean, you could call it left and right, you could call it up and down, you could call it rectangles and triangles. It doesn't matter. There's two values. It's a base 2 system. There's two values. 0 and 1 are labels for these two values in a base 2 system.
Are the labels on and off then?
Yeah, they could be. Well, I mean, 1 is on and 0 is off. And the reason we consider them on or off is because we're talking about the essentially the switching state of the transistor. Either there is a current flowing through this transistor or there is not. So we would say, a computer built on transistors and electricity is on when it is, when it's 1 is the bit value. Now we use arrangements of transistors called logic gates to build a computer. So with logic gates you can build a thing called a latch, which is part of, with transistors you can build a latch, which is part of, that's how memory is made. A latch either, it stores a value. It stores a value of 1 or 0 and it will hold on to that value. Or you can build stuff that is like simple, what we would call Boolean, which means base 2, Boolean logic. So Boolean logic is like this and that, this or that, this exclusive or that. Exclusive or means and doesn't count. Or is true. Okay, I'm getting way too deep into this for 5 minutes.
This is a lot. Okay. How's that rabbit hole doing?
Yeah, I just realized I only have a minute left, so I'm gonna go. There's a constraint built into this podcast for a reason.
I need to set this phone when you're talking at me about these things.
Yeah.
Okay.
Except for I'm not going to stop then.
No, you're not.
So anyways, it switches. So if you wanted to build a computer out of water, you would start building switches. You would build buckets and levers that, when this bucket fills up, it can maybe switch off or on based on, the presence of water in these buckets. And they can, the buckets can tip over and fill other buckets, and that's how you would connect them together using gravity. So you'd have to build something very, very tall if you wanted to build any sort of a complicated computer out of water and buckets and levers, but it is possible because the fundamental unit of computation in a base 2 system is a switch. And so that is how we can build a computer, is with things that switch, like a switching transistor, for example.
Okay. All right. So that was 5 minutes. I don't even know how, oh my God. So I shouldn't say this, but I don't even know how to build like a 30-minute podcast on this, but actually you could.
I mean, I could talk about this forever. We could just go down all kinds of different directions with it. Like, can you build computers out of something that's not a switch? Can you build computers that switch 3 ways instead of 2 ways? There's all kinds of stuff we could talk about. But.
Oh my gosh. We're going to end up building this in like our backyard. He's going to make something really tall with buckets and water and be like, welcome to my computer.
Look, we're doing addition. It's computing addition. That would actually be pretty cool.
Would it?